Okay, guys, this next lesson is still solving equations with variables on both sides, but I'm going to talk about two different cases that will happen that are not like the others that we've been getting. We've been getting answers. We're going to talk about things that, equations that come out to be what's called an identity or a no solution. So let me show you what each of those looks like. Looking at letter A, we have 10 minus 8a equals 2 times 5 minus 4a. Now we still follow the same rules. We have a distributive property, so we need to take care of that first. That's always what we want to take care of first there. So on the left, we get 10 minus 8a equals 2 times 5, we get 10. And then 2 times negative 4a, we get negative 8a. All right, and then we need to, like I told you yesterday in class, we need to get the variables on one side of the equation. So we can decide either do we want to go to the left or the right. What we'll do is we'll look at this negative 8a and we'll move it to the left. So if we add 8a to both sides, I want you to see what happens here. These cancel and you're left with 10 equals 10. Okay, so what happens is we get rid of the variable. And then what happens is we have two numbers left, 10 equals 10. This is a true statement. So when we have a true statement, we call this an identity. What this means is that it doesn't matter what numbers we plug in for A, we're always going to get an equivalent on both sides. So if we were to plug in any number, it doesn't matter what number it is for A, we would still get two equal statements. So that's what we call an identity. Okay, it has infinitely many solutions. It's got infinitely many solutions, and we call that an identity. Okay? All right, so let's look at letter B. All right, letter B, we need to get the 6 m's on the same side. So let's just pick a side. I'm going to move this over to the left. So it's a positive 6 over here. So when I move it to the other side, we subtract 6m from both sides. When I cancel those out, we get negative 5. Bring down your negative 5 equals 7. Now when you eliminate your variable and you come down to a statement like this is something we call no solution. There is not a single solution, a number that I can plug in for m that would make this equivalent statements. So in this case, there's no solution. So the difference in the two is on identity, there's infinitely many. Okay, it doesn't matter what number you plug in for A, you're still going to get a true statement. Whereas over here, there is not a single number that you can plug in that you're going to get an equivalent statement. So this is no solution. All right, let's look at letter C. Letter C, let's go ahead and move. Let's see, we've got a 5 in here. We're going to subtract 5 in from both sides. They cancel out, so we eliminate that variable, and we get 9 equals negative 1. So again, this one is no solution. All right, on number 9, we can't be moving stuff around yet because if you notice on the right side of the equal sign, we have two values that need to be put together, a positive 9 and a negative 2. You should always combine like terms before you try to start moving stuff to the left or the right. So if we look at this, we can go ahead, and actually I believe this one's going to go ahead and give us a solution, but let's go ahead and combine our like terms. We get 9 plus 5x equals 7x, and then 9 minus 2 gives you plus 7. Okay, so now let's do what we did yesterday in class. Let's take one of these to go to one side or the other. It doesn't really matter which we do. So I'm going to go ahead and move this 7x over to the other side. We get negative 7x. So those cancel. Bring down our 9. We get 9 minus 2x, because 5x minus 7x is negative 2x, equals 7. All right, yeah, this one we're not eliminating the variable. So this one we're actually going to get a solution. From here we want to get negative 2x by itself, so we subtract 9 from both sides. Bring down our negative 2x. Negative 2x equals negative 2. Divide both sides by negative 2. And that will get you x equals 1. So this one, in fact, did have a solution. All right, so this is how you decide if you have something that either has identity or no solution. Thank you for listening.